I'm the co-founder of NapthaAI, and today I'm going to talk a little bit about what I think the next paradigm in AI is. So everyone says the 2025 is going to be the year of agents. What is the year of 2026 going to be? I think it's going to be the year of multi-agent AGI. Okay, so let's talk a little bit about the previous generations that we've seen across the last few years. Just about 1 year ago, everyone was saying that scaling is all you need. We just need to scale model training to get to AGI. And in about April of last year, Sam Altman suggested that the era of giant AI models is nearing an end. We're still seeing some performance benefits from scaling model training, but those performance benefits are diminishing. And that was kind of announced to the world with the release of O1. That kind of announced this new paradigm that we're moving into, which is one of inference time compute. And what is inference time compute? Well, we saw a little bit about that in the previous talk, but the idea is that rather than just making a single call to a model, we make many calls to a model. And what we find is that smaller models that make many calls to the LLM can actually improve in performance compared to a single call from a larger model. So we've seen some examples of this. We've seen O1, we've seen deep research by Google and by OpenAI. Of course, DeepSeek R1 was the first model that was released open source and really popularized this. And yeah, we can see that people are now trying to scale this inference. Like, what happens if you make 1,000 calls to a model, 1 million calls to the model? How does that improve performance? And that's what we see in the graph to the right. So this new paradigm was kind of clear for quite a while. Even since the release of frameworks like LangChain, for example, people were playing around with things like chain of thought, tool use, all of these sorts of things. But as I mentioned, it only really became mainstream very recently. So what are we seeing in the research and in the libraries that give us a hint about what the next paradigm is that isn't yet mainstream? And so these are some research papers that I think give a hint as to where we're going. So the first one is more agents is all you need. People might have heard of this. And what people are trying to do is scale the number of calls to many different agents or many different models. So what's the difference with inference time compute? With inference time compute, we're making many calls to the same model. With this new paradigm, we're making many calls to many different models or many different agents. And what we see is that in the first graph to the top right, we see that as we scale the number of agents or number of LLMs, we see a performance increase up until about 35 agents. The second paper is called Scaling Large Language Model-Based Multi-Agent Collaboration. That's the graph on the bottom right. And what they saw was that scaling up to, I think it was a little bit over 1,000 agents, sees increases in performance before leveling off. And they tried a few different types of collaboration. So the one that I'm showing is like a random interaction pattern. They also tried like maybe 5 other interaction patterns, but they saw this performance increase across all of these different ones. So why do we see an increase in performance with many different models or many different agents? Well, the answer is heterogeneity or diversity or pluralism. So, this first paper here, Mixture of Agents, what they found was that LLMs tend to generate better responses when given outputs from other models. And the reason for that is that, if you make a call to one LLM model, it might have one failure mode, but a different model might have a different failure mode. And these different models tend to pull each other out of these different failure modes. And so scaling to many different models means that we reduce the amount of failure modes, and it has a bunch of advantages. This second paper found that diversity of different models that engage in debate with each other also improves performance. And it's not just diversity of models as well, but increasing the diversity of other things like architecture, local knowledge, and tools also improves performance. So what is the architecture? Well, we saw in the last talk about things like chain of thought. You can think of the architecture like the loop that makes calls to the LLM. And you can have different types of loops. Maybe one of them uses chain of thought. Maybe one of them uses a different type of reasoning approach. Maybe one of them retrieves from memory. These are all different architectures. And what we find is that as we increase the number of different architectures that we use in a multi-agent system, we also see an increase in performance. So there's quite a few challenges for AI engineers and researchers building multi-agent systems at the moment. So one of them is that we're just starting to see a lot of different open source models which can do tool calling, but it's still super early. And each different open source model has a different format for tool calling. And we're starting to see the same thing for reasoning models. We've only really seen like 1 or 2 open source reasoning models. And the way that these models reasoning, the way that they output these reasoning traces is all different. So if you've used DeepSeek R1, for example, it might, it shows you the reasoning trace. It might say, step 1, I would need to do this. Step 2, I need to do this. The format of that is always different. And that creates headaches for AI engineers and developers that want to build multi-agent reasoning systems. So another one is structured output varies. It's hard to get different models to adhere to structured output. And there's also a few standards for agent interaction. So how does one agent request a task from another agent? How does it interact with another agent? These are all things that we don't have standards for yet. So what I think we need is some sort of like platform or operating system that establishes a set of standards for all of these different multi-agent systems to interact. That's what these Google executives raised money to build the Android of AI agents. That was just recently. We've been working on something like this for a few years now. So what is NapthaAI? NapthaAI is a framework and infrastructure for developing and running multi-agent systems at scale with diverse models, architectures, and data. We just released, we did a V1 release this week. Check out the repo. It's actually naptha-node, not node. We changed that last minute. But what you get with the naptha node is the ability to run a lot of agents locally and for those agents to interact with other agents running on different nodes. So you get support for about 16 different models with standards for tool calling, for structured output. Those agents can store knowledge and memory locally. And as I mentioned, they can interact with agents running on different nodes through different communication protocols. Then, so that's the platform, that's the OS. And then developers can build applications on top. What is a NapthaAI module? You can kind of think of it like a container for an agent. So you can create an agent using another framework like CrewAI or LangChain. You can wrap it in a NapthaAI module, and that enables that agent to interact with other agents, even if they're written in different frameworks or even in different languages. So we're kind of framework agnostic. So why build multi-agent AI? Well, as I mentioned, we see a lot of performance benefits with multi-agent systems, but I also think multi-agent AGI is safer. What happens if AGI is a single entity and it goes rogue? Well, then you're kind of screwed. But what if AGI is a system of billions of agents and 5% of them go rogue? Well, hopefully the other 95% can compensate for that. Building multi-agent AGI requires a number of different skill sets. We need to think in terms of AI economies. We need to think in terms of game theory. We need to think in terms of social science. So we need a bunch of different professions working on this. So if you're interested in helping to work on multi-agent AGI, please reach out. I'd love to chat.